check out number 3. On number 3, find UC if UQ is 2x minus 4. So, UC. Now, I'm looking for UC, but I know the whole thing, UQ, is 2x minus 4. Okay? So, UC, from here to here, is that the bigger chunk or the smaller chunk? What do y'all think? Okay, so UC is the bigger chunk. Is that 2/3 or 1/3? 2/3. Remember, whenever you have the median, the bigger part's 2/3, the smaller part's 1/3. So UC is 2/3 of this whole thing right here, okay? 2x minus 4. So what I want to do is to find UC, I'm going to take 2/3. Typically, we do 2/3 times a number, right? But in this case, we don't have a number. We have an expression, okay? 2x minus 4, okay? And check it out. We have CQ from here to here. This is x minus 4. Okay? So, what we're going to do is if we know 1/3 of it is x minus 4, and 2x minus 4 is the whole thing, then we can make an equation based off what we know. So we know, I'm going to make a little statement right here. We know that CQ, the smaller part, is 1/3 of the whole thing, UQ. Okay? Do you all agree? Small part equals 1/3 whole part, right? So what I'm going to do is I'm going to replace CQ with this, and I'm going to replace UQ with this. Okay? So let's do that. CQ equals x minus 4, and that equals 1/3 of, and I'm going to plug in UQ to x minus 4. All right. If I do this, I'm going to be able to solve for x. So what I'm going to do is, I know this might be kind of weird, but I'm going to be able to distribute a fraction here. So x minus 4 equals 1/3 times 2, x is 2/3 x. 1/3 times negative 4 is negative 4 over 3. Okay? Now, how many of y'all have heard of the phrase clearing the fraction? It should be something hopefully you learned maybe in middle school. Do y'all see how we have these divided by 3's here? We have these fractions over 3. Algebra is so much nicer to do when there's no fraction. Yes. So there's a kind of a trick to get rid of a fraction. Okay? I look at my bottom part of my fraction, the denominator, and if I can multiply everything by that denominator times 3, I'll have no more fractions. Okay? So that's what I want to do. I'm going to clear the fractions. Okay? So this is 3 times, maybe I'll make it 3 times all that. So 3 times x, it's like a big distribution problem. 3 times x is 3x. 3 times negative 4 is negative 12. 3 times 2/3 x. If you type it in your calculator, you'll get 2x. 3 times negative 4/3 will give you negative 4. It basically just gets rid of the bottom number of the denominator, if it's a fraction, right? So this is more doable. If I'm going to solve this, again, x is on both sides like we've done before, so I get rid of the smaller x, minus 2x, minus 2x. It gives me a 1x over here, bring down minus 12 equals negative 4. And then to get rid of minus 12, I add 12 to both sides. And I get x equals 8. Okay? So x equals 8. And if I know x equals 8, I can plug it back in and figure out the length of QU. Okay? So QU, all the way across, 2x minus 4. So to find QU, 2x minus 4, I'm going to plug in down here, x equals 8. So that x is going to be 2 times 8 minus 4. Okay? 2 times 8 is 16, minus 4 is 12. Okay? So QU is 12, this whole thing. So, if the whole thing is 12, I'm trying to find UC. That was my final objective, right? And we said at the beginning, UC is 2/3 of the total. So if the total is 12, to find UC, it's going to be 2/3 times 12. Okay? If you take 2/3 times 12 to the calculator, you'll end up getting 8. Okay? Now that was a long, drawn-out problem. Okay, that's one of the more challenging ones, but that's why we're showing you how to do it. You set up two things you know as an equation, and then you solve it. Okay? Now looking at your assignment, which we're not going to pass out yet, but there's only one of these challenging ones on it. Okay? Most of them are like 1 and 2 on the prior page. Okay? And then we're down here on number 4. You should be able to, from a diagram, make a centroid. So what does it say? The diagram shows the plan for a triangular piece of a mobile. If you don't know what a mobile is, ask an art student. Hopefully they know. Where should the sculptor attach the support so the triangle is balanced? So from now on, if you see the word balanced, I want you to think of what you constructed today. Didn't we make a triangle that balanced? Or we should have, right? So we're talking about a centroid. They didn't say the word centroid, but they did say the word balance. Okay? So balance, centroid. Balance, centroid. So, how do I make a centroid? Well, you tell me. What did we do? First thing we did was find what points? Along the edge. When we folded, those were called the midpoints, right? So first thing we need to do is find the midpoints. So, how do I find the midpoint of these segments? What do y'all think? There's an algebra way. Y'all like having to do a bunch of equations and stuff? Or there's kind of a practical way. Which one do you want me to show you? Practical? Okay, so check it out. Let's say from Y to P. If I want to find this midpoint, I'm going to look at the X values. Okay? Can you find halfway between 0 and 3? 1.5, right? And then if I'm trying to find the middle between 0 and 8, that's 4, right? Between half of 8 is 4. So if I go over 1.5 up 4, there's my midpoint. It's half of the X's and half of the Y's. Boom. Let's try that over here with P to R. Okay, between P and R, that's 3 units, so halfway is 1.5. This is 4 units, so half of that is 2. So over 1.5 up 2. Okay, I'm not guessing. I'm actually finding half of my X, half of my Y, and putting a point there. Okay. So again, there is a way using midpoint formula to find the exact number where you add up the X's and divide by 2, add up your Y's and divide by 2. But I'm saying this is totally fine if you know what you're doing. So half of my X's from Y to R, that's 0 to 6. Halfway between 0 and 6 is 3, right? And then from here to here, this Y to this Y, okay, that goes up 1, 2, 3, 4, 5. Half of 5 is 2.5. Wait, 1, 2, 3, that's 4, my bad. Can't count. So there's 4, so half of 4 is 2. Okay, so we found our midpoint is right there. No. So like I said, we don't eyeball it, but we don't have to do a formula if we know half of the x, we count that's 4, half of 4 is 2. This is 5, this is 6, half of 6 is 3. So I wouldn't call it eyeballing, I would call it, intuitively reasoning. Okay? Because I've had too many students be like, I think that's the midpoint, and they're wrong. So I want y'all to have a reason why you're putting your point where you put it, because it's half of the x's and half of the y's. Okay? Now, you should still have something straight to draw with at this point, so you're going to be drawing a median. So just do your best. So from the midpoint to the opposite vertex. Midpoint to the opposite vertex. If you do those two first, you'll see where the other one's going through. And there's your centroid, okay? So the balance point, again, for balance, that means centroid. We did 3 medians, and those 3 medians crossed at what coordinate? So can anyone tell me the x, y coordinate of that point? What's the x, comma, y coordinate for that point? This is what? 3, 4. Very good. Now, could you do that on your own? That's the hope. All right. So I'll get the assignment into your hands. It does say a happy belated Thanksgiving on it. But on the assignment, okay, this is like 2 assignments in one. The back side of the assignment is stuff we haven't done yet. So you don't have to finish it, but you do have to keep it because it's not done until we've gone over that part. Okay. So just the front side. We're just getting started. It's not homework. We're going to have class time tomorrow to work on it, so don't stress over it. You got time tomorrow in class, okay? So let's get started. Use the rest of our time in class wisely to get a head start on this.